Hello there. I'm Matt Walburn, leader of the People and Product Operating Model practice within Amazon Web Services Professional Services Organization. This webinar is going to cover how to build your Cloud Enablement Engine and also to help you understand key success criteria and patterns that we see helping customers to accelerate and sustain their adoption of AWS by transforming their workforce as well as their operating model for life in the cloud. We're going to cover 7 key areas today. Number 1, we'll review what is an operating model. We'll define this term in terms of the business and IT, including common areas of misalignment that we see between the two. Number 2, activity-based operating models. We'll talk about the challenges with activity-based models, which is what we commonly see in enterprises. Number 3, transitioning from activity-based to product-based operating models, in which we'll discuss the differences between these two models and the advantages of moving to a product-based operating model as part of your move to AWS. Number 4, the Cloud Enablement Engine. Cloud Enablement Engine is the product-based organization that will enable the rest of your organization to adopt AWS with speed and safety. Number 5, accelerating organizational readiness with training. We'll discuss the importance of giving the people in your organization access to the right training at the right time. Number 6, 5 questions to think about now. We'll provide some homework for you to think about as we help you prepare for one of our workshops, which is one of our key number 7 next steps. So to start off with, what is an operating model? There are many definitions of operating model, but we like to put it simply. An operating model describes how the business and IT align their capabilities, processes, ways of working, and their people to achieve the enterprise's strategic business objectives. Unfortunately, most business and IT organizations are not aligned. In most organizations, there are actually 2 operating models that are not in strong alignment: the business operating model and the IT operating model. The business tends to be focused on the capabilities or products that it provides to customers. Meanwhile, IT is focused on deploying technology capabilities that may have nothing to do with the business. They have completely different processes for how they accomplish their work, and their workforces usually sit in separate buildings and almost never talk to each other. This creates misalignment in the outcomes that they are trying to achieve. The business may want to build new business capabilities or customer-facing products. Meanwhile, IT may be focused on operational excellence. When you're building new experimental products, you may not have the highest levels of stability or performance. So these 2 things are in conflict. The business may be looking for increased speed and agility. Meanwhile, IT may be looking to cut or optimize costs. Sometimes you have to go fast, and in order to do so, you need to spend more money. So at times, these things are also in conflict. The business is ultimately looking to deliver business and customer value. In other words, results. Meanwhile, IT may be laser focused on security and compliance. This may create an environment that is so restrictive that it impairs the business's ability to produce the expected results. So these things are also in conflict. This lack of alignment is especially concerning in today's business environment, given that more and more of the products being produced by enterprises are digital products, where alignment between the business and IT is crucial to the success of those products in the market. A great deal of this misalignment comes from the fact that the organization, both business and IT, they are organized around activities or functions being performed, where each piece of the organization owns a different piece of the end-to-end value stream that turns ideas in the business into value in the form of software-based products accessible to end users. We'll use this simple 2x2 diagram to illustrate the point. On the vertical axis, we have infrastructure and applications, and on the horizontal axis, we have engineering and operations. Applications refers to the business software that can be either custom developed or purchased. Infrastructure is everything that supports those applications, physical or virtual infrastructure, or software-based infrastructure like middleware and databases. Engineering is the development, building, and testing of applications and infrastructure. Operations is the deployment, operations, and ongoing support of this applications and infrastructure. In most organizations, each of these quadrants is performed by a separate piece of the organization. Application engineering is done separately from application operations teams, and infrastructure engineering is also done separately from work being done by infrastructure operations teams. Work is passed between these teams using an IT service management platform, passing work requests between teams using work queues and tickets. A great deal of this misalignment comes from the fact that the organization, both the business and IT, are organized around activities or functions being performed, where each piece of the organization owns a different piece of the end-to-end value stream that turns ideas in the business into value in the form of software-based products accessible to end users. In practice, these local optimizations cause the flow of work across the overall value stream to be sub-optimized. As work is handed off from team to team, bottlenecks and delays are created. Teams are incentivized to work quickly to maximize their throughput, but in the process, they frequently create defects that are passed downstream, resulting in rework. If the defect is caught early in the value stream, the rework may be minimal. But if a critical security defect is found late in the delivery process, it could cause rework to be done in design and engineering, causing the entire value stream to be exercised all over again. Each handoff and defect delays time to value, which is the most pressing concern for modern digital enterprises. We've already covered handoffs and defects, but there are other forms of waste in this kind of operating model. Extra features. Features that are scoped and built, but never actually used by consumers. Task switching, the act of switching between contexts and tasks. Research shows that every time you switch contexts, that productivity may drop between 20 to 30%. If you are managing more than a couple of initiatives, you can very quickly see productivity erode to zero as most time is spent reestablishing context. Relearning. We see this most often in projects, the primary form of execution in a project-based organization. The business has an idea, funds an idea, and then creates a project team to deliver that idea. After the project is finished, the software output is turned over to operations and support, and the project team is disbanded. If a major feature, enhancement, or risk or fix is required later, the support team must reestablish context, relearning the codebase and the operating environment to implement that feature. Wash, rinse, and repeat over and over. Delays. Most, if not all, of these forms of waste cause delays, another form of waste. And finally, partially done work. In organizations where projects are the primary means of delivery, resources are typically allocated to multiple projects. This drives up task switching for individuals, but it also drives up large amounts of partially done work. This is also known as work in progress throughout the organization. In other words, many things are started, but few are finished. To better align the business and IT, it helps to consider and accept that no single approach to IT will support all areas of the business. At AWS, we segment and align our approach to operating models to three high-level categories of desired business outcomes. Number one, sustain. These are areas of the business that at one point may have been strategic, but have now either stagnated or are in decline. Making deep investments in IT to support these areas of the business doesn't usually make sense. Optimizing cost, doing the bare minimum to keep the lights on, or even outsourcing or retiring these workloads may be a better way to go. Number two, optimize. These are the current core areas of the business as it exists today, providing or supporting significant revenue. Any disruption significantly impacts core business operations, making investments in resiliency, availability, security, scalability, and performance mandatory. Number three, grow. These are areas of the business where the priority is growth, either by taking market share from competitors or creating net new differentiated digital products. Since uncertainty and ambiguity is high for these aspects of the business, the ability to iterate quickly, to learn, to hypothesize and experiment, and to use continuous delivery and A/B testing is non-negotiable. Now, let's go back to our 2x2 diagrams to discuss how each of these business outcomes changes who is responsible for a given set of capabilities and processes within these three different operating models. Sustain. You can also think of this as traditional operations. This is nearly identical to the traditional activity-based model that we discussed earlier. Just as you lift and shift workloads in this model, you also lift and shift your traditional operating model. Application engineering is still done separately from application operations teams. We now have a cloud platform engineering team instead of multiple infrastructure teams, but we have a separate cloud platform operations organization that is separate from engineering. Optimize. Here we start to see the broadening of responsibilities for both the application and platform teams, with activities turning into outcomes. The application engineering team is now also responsible for application operations. Think of this as DevOps for the application team, where they own the full outcome of delivering and operating their application. Similarly, Cloud Platform Engineering now owns engineering and operations of the platform services that they provide to enable application teams. This Cloud Platform Engineering team is now a DevOps team as well. This implies a shared responsibility model between the application and platform teams. Platform teams provide the codified enterprise standards and governance that enable application teams to iterate quickly without burdening them with knowing deep implementation details of the underlying platform. We also refer to this as a distributed DevOps model because the DevOps responsibilities are distributed between application and platform teams. Grow. For teams that are on the bleeding edge of technology, looking to consume the latest AWS services as soon as we launch them, we offer this model. Application engineering is responsible for their applications, but in order to avoid stifling innovation for high growth areas of the company, we also empower them to build out platform capabilities that have not yet been standardized by the Cloud Platform Engineering team. Cloud Platform Engineering is still present, but in a reduced capacity to provide standard accounts and security guardrails that prevent these cutting-edge application teams from configuring AWS services in a way that would expose the enterprise to inappropriate security, financial, or operational risk. We call this model decentralized DevOps because the platform responsibilities have been decentralized away from the Cloud Platform Engineering team in this model. The three models do not imply levels of maturity. In fact, we see all three of these operating models present in most companies. That said, there's almost always a gravitational pull back to optimize. Sustained workloads eventually get retired or outsourced, and the platform services used by grow workloads eventually become new enterprise standards. This allows even the most cutting-edge teams to ultimately be supported by the Cloud Platform Engineering team, so that these application teams can focus on adding new digital business value rather than doing the undifferentiated heavy lifting of maintaining platform capabilities. Because building out an operating model can take considerable time and investment, AWS recommends focusing this energy on your more strategic and mission-critical workloads, optimize and grow, and not on your legacy sustain workloads. AWS Managed Services can be a valuable tool to help accelerate production-ready operations for this portion of your portfolio, allowing you to focus on building people and capabilities to support, optimize, and grow models longer term. AWS Managed Services provides ongoing management of the AWS infrastructure supporting your sustain workloads so that you can focus your energy on the more differentiated optimize and grow workloads. Some of the services that AMS provides and manages on your behalf include change management, incident management, provisioning management, access management, patch management, continuity management, security management, ITS integration, as well as reporting. If you're interested in a deeper dive on AMS, please talk to your account manager. Your business's desired outcomes may also impact how you decide to migrate your workloads. We use the 6Rs framework to define different migration paths. So first, a little background on the 6Rs. Rehost refers to moving your workloads as is from your data centers to AWS with minimal changes. Replatform refers to moving components of a workload's architecture to AWS implementations. Examples would be moving an Oracle or SQL Server database to RDS versions of these services, using elastic load balancers instead of traditional load balancers, using elastic file service instead of server or NAS-based NFS or CIFS implementations. The underlying architecture is intact, but improved by AWS. Repurchase refers to retiring the existing workload and either purchasing a new third-party solution through either packaged software or software as a service. Refactor refers to fundamentally re-architecting and rewriting the application to take advantage of more AWS native services, such as decomposing a legacy monolith into microservices that leverage AWS services such as Lambda, DynamoDB, and API Gateway. Retain refers to workloads that you may never move to AWS. And finally, retire refers to workloads that have reached the point where it no longer makes sense to maintain them on-premise or on AWS. Combining our 3 operating models with the 6 Rs can help keep your migration strategy aligned with the outcomes that the business wants to realize by moving to AWS. Sustain, rehost. Many customers will migrate most of their workloads using this migration pattern and the traditional operating model. This is the fastest means of migrating, so if a customer is looking to quickly exit a data center, this can be a strong starting point for the entire portfolio. That said, over time, most customers will want to align the optimize and grow portions of their portfolios to align with their representative Rs and operating models. Optimize, replatform, or repurchase. Replatforming is going to allow the business to continue to optimize in terms of resiliency, availability, security, scalability, and performance with minimal change to its architecture. Repurchasing may allow them to reap these benefits without carrying the operational burdens associated with the existing solution. Distributed DevOps would be the best fit for workloads using the replatform or repurchase migration pattern. And finally, grow, refactor. Some workloads may need to be refactored entirely in order to maximize the ability for their development teams to iterate quickly, to test and learn, to hypothesize and experiment, and to use continuous delivery and A/B testing. This is the most invasive migration pattern, but can be worth it for areas of high growth and differentiation. Decentralized DevOps may be the best fit, at least initially, for workloads using this migration pattern. Over time, we recommend that you focus your energy on building operating models that support, optimize, and grow workloads. This means transitioning your sustain workloads either by retiring them, repurchasing them as SaaS-based solutions, or re-architecting them to take advantage of one of the other operating model patterns. We consider the optimize and grow operating models to be strategic as they enable your teams and the organization to treat both applications and platform as products, which is the next topic in our briefing. Before jumping into product-based operating models, it's helpful to discuss the Amazon flywheel, which in many ways captures the way that Amazon's retail business operates. We'll then compare this to another flywheel that describes how Amazon develops and delivers software and services. If you know anything about Amazon, you probably know that we consider ourselves to be the most customer-centric company on the planet. And as such, we always start with the customer experience and we work backwards from there. Creating an experience that delights customers drives traffic to Amazon.com. The more traffic Amazon.com receives, the more attractive the platform is for our sellers. The more sellers that come onto the platform, the deeper and broader our product selection becomes. There's a reason our customers refer to us as the everything store. And this expanding selection then drives an even better customer experience, causing the flywheel to spin faster and faster. This drives growth for Amazon.com, which we then reinvest into the company to lower our overall cost structure. This allows us to pass on benefits to customers in the form of lower prices, which in turn drives additional levels of improvement in the overall customer experience. A similar way of operating drives the flywheel behind our ability to rapidly deliver software and services. Let's call this the flywheel for digital products. We still, as always, start with the customer experience and work backwards. Providing a superior customer experience drives adoption of our software and services. And the more adoption of our software and services, the more feedback, meaning data, telemetry, and insights, we're able to capture on how our customers are using, and maybe even more importantly, not using our software and services. This provides us with a customer-centric, data-driven approach to decision-making around which experiments we should perform next. Experiments can take many forms. They can be new features, enhancements, an entirely new product, or even bug fixes and security patches. Using this data-driven approach to prioritize the right blend of new features, refactoring, and risk mitigation allows us to continue to further enhance the customer experience. While this drives growth for our software and services business, it also drives an expanding customer value proposition. We accelerate the delivery of value with 3 more components of our flywheel. First, we decouple. This means decoupling our architecture, but also our teams. A decoupled architecture means that teams can more easily make changes and add new features without disrupting other teams. It reduces the amount of communication and coordination that is required in more traditional software teams. As part of decoupling our teams, we empower them to own their piece of the architecture, their product, as if it were its own small business. They own the business strategy, the P&L, the design, engineering, and ongoing operations of this small business. They are also held accountable for delivering results and high levels of quality. When you apply these concepts across hundreds and thousands of 2-pizza product teams working in parallel, we improve the organization's time to value, the time that it takes to perform and validate an experiment with a customer, orders of magnitude faster than traditional enterprises. This is what allows us to continuously improve our customer experience, deploying a new experiment to improve our customer experience every few seconds. This flywheel represents a product-based operating model, powering both customer-centric innovation as well as modernization. We can apply this product-based model to how we deliver both cloud platform services to the organization, as well as the business applications that consume those services. Customers realize maximum value from AWS when they build their own flywheels. This means that you can't stop at migration if you want to fully realize the benefits of our platform. Migration is absolutely the first step, but we want to help you use AWS to reinvent the way that you deliver digital products to your internal and external customers. If you want to implement a product-based operating model in your organization, either for the delivery of cloud platform services or business applications, 6 key changes are required. We'll build out a grid here that shows the transition involved in each change. We'll show what we see in most organizations and what the change is from status quo. Number 1, work backwards from the customer. Most companies make guesses or inferences about what their customers want. They imagine and they have hunches or feelings about what customers are looking for. Unfortunately, this increases the odds of being wrong. If we want to be more customer-centric, even customer-obsessed, we need to move from imagining to knowing. This requires us to spend time to get to know the customer, to find out what delights them and what pain points they have. Ideally, we have and use data to prove that we truly know our customers. Then we think of what the best solution might be to address their pain points, narrowing the list until we arrive at what proves itself to be the simplest way to solve their problem. Number 2, re-envision the world as products. In many companies, systems that support the business are large, complex, tangled messes of functionality that have developed organically over time. Once upon a time, Amazon was no different. The system that supported the Amazon.com business was a large Java-based e-commerce application. In order to move to a product model where we could drive adoption and reuse of the functionality within Amazon.com for other purposes beyond retail, we first had to reimagine what those individual products would look like. Examples might include homepage, customer account, search, shopping cart, item management, digital asset management, and others. It's important to note that envisioning is not the act of refactoring the architecture. Refactoring cannot happen until we know what the components of that future architecture will ultimately be. Number 3, organize teams around products. In most large enterprises, teams are organized by function or activity. You have a team of business analysts, program managers, designers, architects, managers, and developers, for example. And if you want to decouple your architecture, you first need to decouple your teams. This means organizing self-sufficient teams around your future products. And in order to be self-sufficient, they need to have all of the skills that they need to deliver the product on the team, minimizing the amount of communication overhead that you see in activity-based organizations. When teams are organized around products, even if the architecture has not yet been decoupled, the friction between the way that the team wants to work and the existing architecture will naturally incentivize the teams to do the technical refactoring. Eventually, the decoupled application will evolve to match the decoupled organization. Number 4, bring the work to the teams. In most enterprises, work is executed in the form of projects. Someone has restart again, I'm sorry.
That's okay. Feel free to begin whenever you're ready.
Number 4, bring the work to the teams. In most enterprises, work is executed in the form of projects. Someone in the business has an idea, a business case is created to get the idea funded. The idea is then funded and prioritized, and finally, a team is pulled together to deliver the project. This is called bringing the team to the work. The team then goes through several phases that I'm sure you've heard of before: forming, storming, norming, and finally performing, eventually completing the project. The application is then typically turned over to enterprise support and the project team is disbanded. All of the expertise and knowledge must then be relearned by whoever makes the next fix or enhancement. If we want to empower our teams to own and run their projects as small businesses, we must first make the teams permanent and bring the work to the teams. When teams are permanent, there is no forming, norming, and storming, only performing. When teams are permanent, the job of higher level management is to ensure that they are working on the highest value work possible. Enterprise initiatives are analyzed to see which product teams would be impacted by delivering that work. The backlogs of the impacted teams are then prioritized to align with the overall organizational priorities. Teams are given the mission, but are empowered to figure out how to execute that mission themselves. And when teams are permanent and empowered, other benefits emerge. The team becomes deep subject matter experts in that product, productivity and throughput improves, quality improves, teams feel more connected to their work and its business impact, teams innovate and create more valuable products. Number 5, reduce risk through iteration. Large enterprises typically have large batch delivery and funding cycles. Delivery may take place over the course of a year with long phases of analysis, design, development, testing, go-lives, and finally a turnover to support. Throughout this long delivery cycle, the organization is accruing risk of delivering the wrong thing to customers. Only at the end of this cycle, when the application is finally in production, does the business find out if they've achieved product market fit. Similarly, these long delivery cycles tend to be funded in large batches, with funding being burned down throughout the project. Again, only at the end do we find out if we've funded the right initiative or if we should have spent our capital elsewhere. This is the risk of incurring opportunity cost. If we want to reduce risks related to product market fit and opportunity costs, we have to increase the frequency of collection and inspection of feedback so that we can learn to make decisions more frequently. This means creating smaller batches of both delivery and funding, and then assessing the feedback we collect to decide whether we should pivot or persevere. Instead of creating the entire product before letting customers weigh in, break up your releases to deliver value incrementally in the form of what Amazon calls minimum lovable products. Each release should give the customer something new to love about the product. If a customer is actually using the product, that's a pretty good sign that there's something to like about it. Instead of annual funding releases, move to something that resembles startup funding. After each release of an MLP, measure to see if the business value that justified building the MLP is actually realized. If it is, release more funding. If it's not, that's an opportunity to change directions or even kill the product altogether, avoiding additional opportunity cost. The best way for our empowered teams to get the feedback they need is to make sure that their backlog is rich with experiments that are designed to increase value to the customer. Obviously, we can only do this if we actually know our customer. Number 6, own your own life cycle. As already discussed, in most organizations, the people that engineer applications and platforms are distinct and separate from the teams that operate applications and platforms. If we want to reduce time to value, engineering and operations have to be brought together. This also increases the frequency of feedback. This means that application and platform teams need to be able to quickly deploy experiments to serve and delight their customers. Giving them accountability for operations and support incentivizes them to make sure these experiments are high quality, that they've been tested, and that things are done right the first time. Now that we've introduced our 6 key steps for moving into a product-based operating model, let's spend a little bit of time giving examples of products. Let's walk through another example of looking at the world as products. We'll use the Amazon.com example again, but in a much more visual way. When you look at Amazon.com, you might be tempted to think of it as a single product. But in fact, our homepage is a combination of many products working together to create the Amazon.com homepage experience. The first product is the presentation of content itself. We can think of this kind of product as an experience. This adaptive homepage adapts to present content differently depending on where the customer is experiencing it. The same homepage renders differently in web browsers on the desktop, mobile phones, tablets, Fire TVs, and even Alexa devices. The adaptive homepage, in turn, pulls content and data from several other products that we could classify as services. Again, examples of this would be search, shopping cart, account management, item management, advertising, promotions, digital assets, and others. And if we looked even deeper under the covers, we would see that each of these products are also talking to multiple additional products and services on the back end. Each one of these products is owned, developed, and managed throughout its life cycle by a dedicated cross-functional product team. By collapsing the traditional idea to value stream, we remove and improve each of the 7 areas of development waste. Handoffs are minimized as all of the skills and roles required to deliver our product are now contained within each product team. Extra features are minimized because we have a cross-functional team of business and IT resources with diverse experiences and perspectives obsessing over the customer. Relearning is minimized because the product team is dedicated with a stable team of resources supporting the entire life cycle. Partially done work is minimized because over time, the team learns how much work they are able to accomplish within a given period of time. Work is completed before moving on to the next priority. Defects are minimized because we have built a dedicated team of subject matter experts that now owns the product throughout its life cycle, from idea to design to development to operations. Task switching is eliminated because our product team is working against a sequenced, prioritized backlog of work for their product. And delays are minimized because most sources of delay are now in control of the product team. Our approach to operating model transformation applies these product principles in 4 key work streams. Alignment between internal customers looking to consume cloud services and the teams that enable them to do so. Enablement in the form of self-service cloud platform products to enable internal customers to adopt cloud more easily. Applications that are customer obsessed, built in collaboration between the business and IT. Leadership to align, champion, drive, and sustain change within the organization. Each of these work streams builds and enables new organizational capability within your business. The Cloud Business Office focused on product management of cloud enablement, financial management of the cloud investment, training of your workforce, and organizational change management to ensure a successful transformation. The Cloud Engineering team develops enterprise self-service capabilities with 2 pizza teams focused on platform, operations, and security. Product teams at scale for organizations looking to transform their software delivery capabilities, integrating the business and IT into 2 pizza teams to modernize your existing portfolio or to create innovative net new applications. And the Cloud Leadership team, who provides the necessary cross-business alignment and sponsorship of your cloud strategy, its desired business outcomes, and the required change program, including setting success criteria and enterprise KPIs to measure results. For the rest of today's discussion, we're going to focus on the 2 platform components of the product-based operating model. Together, the Cloud Business Office and the Cloud Platform Engineering team make up something that we refer to as the Cloud Enablement Engine, your engine for accelerated and sustained adoption of AWS. The Cloud Enablement Engine is a product-based organization. The products that they create enable the organization to accelerate cloud adoption while keeping adoption sustainable and secure. The Cloud Enablement Engine's core mission is to free development teams to focus on maximizing the benefits of cloud with their applications, rather than focusing on platform or governance concerns. There are 2 components of an organization's Cloud Enablement Engine. We'll start at the bottom and work our way up. The Cloud Platform Engineering team configures and codifies the AWS platform to align with enterprise standards for architecture, operations, security, and finance. They also package and continuously improve these standards as self-service deployable products and consumable shared services. The Cloud Business Office aligns the products and services offered by Cloud Platform Engineering with the needs of its enterprise customers as well as leadership. They also provide the ongoing onboarding, training, and organizational change management to ensure the organization successfully navigates and embraces its move to life in the cloud. The Cloud Business Office aligns the products and services offered by the Cloud Enablement Engine with the needs of its enterprise customers and leadership. The capabilities that the Cloud Business Office provides are broken into 2 categories. Number 1, business and governance, and number 2, people enablement. Business and governance covers 4 domains. Number 1, architecture alignment. Architecture alignment provides alignment between enterprise architecture and the Cloud Enablement Engine, establishing processes to evaluate and develop new cloud patterns to support teams looking to adopt AWS. Number 2, product management. Product management is responsible for understanding customer requirements and demand for cloud products and services. They then translate requirements and demand into a prioritized backlog of work for the Cloud Platform Engineering and Cloud Business Office product teams. Number 3, delivery management. Delivery management develops and maintains the structure to manage the delivery of items within the Platform Engineering and Business Office backlogs, while managing status reporting to the Cloud Leadership Team and the Enterprise Project Management Office. Number 4, financial management. Financial management provides mechanisms to accurately allocate, forecast, and optimize spend by consumer. They enable self-service capabilities for customers and executives to manage current and forecasted spend. People enablement covers 3 domains. Number 1, customer onboarding. Customer onboarding is an internal team of cloud consultants that help guide customer teams through the process of migrating to the cloud, including training, deployments, migration, and the transition to steady state operations. Number 2, training. Training provides consistent training curriculum and delivery to teams throughout their development lifecycle, beginning with foundational training all the way through content for subject matter experts. Number 3, organizational change management. Organizational change management establishes the overall cloud strategy to be delivered and enabled by the Cloud Enablement Engine, partnering with the cloud leadership team to drive successful implementation across the organization. The Cloud Platform Engineering team codifies differences between stock AWS service configurations and enterprise standards, and then packages and continuously improves them as self-service deployable products to their customers. Platform establishes core shared platform capabilities and codified patterns to enable enterprise self-service deployments by application development teams via a service catalog. Operations establishes core shared platform capabilities required to enable automated build and release processes, end-to-end day 2 operations, integration of operations products across all of the codified patterns, as well as self-service deployments, alerting, and reporting. Security establishes codified corporate security policies and controls in the cloud, leveraging automation and self-service tools whenever possible. Proactively assess and monitor the environment to enforce security policies and to mitigate threats. The Cloud Enablement Engine's teams support many internal customers. Again, the Cloud Enablement Engine is made of 2 components: the Cloud Platform Engineering team and the Cloud Business Office. The Cloud Enablement Engine is put in place to enable software development teams and the applications working in all 3 operating models: sustain, optimize, and grow. For the sustain operating model, the Cloud Enablement Engine must also enable traditional operations teams as well as traditional security teams. The Cloud Enablement Engine must also consider and integrate requirements from various sponsors and executives. Number 1, the Cloud Leadership Team. This is a cross-functional group of executives from the business and IT that champion and drive the cloud adoption strategy throughout the organization, as well as other key executives that will have requirements on how the organization adopts AWS. The CFO may want to ensure that the cloud investment is managed responsibly. The Chief Information Security Officer will want to ensure that cloud adoption does not compromise enterprise security. And the Chief Technical Officer may want to ensure that enterprise technology and architecture standards are being upheld, and so forth and so on. As you can see, the Cloud Enablement Engine must satisfy the needs of many customers, which is why the product management discipline and the product operating model is so important. We don't recommend building an entire Cloud Enablement Engine all at once. Instead, at AWS we say, think big, but start small. This gives your team and its customers the opportunity to build and learn iteratively and incrementally as they scale their adoption of AWS. The Cloud Foundation team is your first product team, and because it's a product team, it's cross-functional and represents all the roles and capabilities that will eventually scale into the full Cloud Enablement Engine. Within the product team, we are trying to balance 4 concerns. Viability from a customer and business perspective is supported by 2 roles. 1, the product owner, who is singularly accountable for the Cloud Enablement Engine's vision and its viability from a business perspective. And also a financial analyst responsible for financial budgeting, tracking and reporting, showbacks and chargebacks, as well as cost optimization. Next, desirability of the products being created and the change being driven throughout the organization. Cloud architects translate customer, business, and governance requirements into product architectures. You may have a single lead cloud architect or architects that represent platform, operations, and security. Also, an org change management specialist who is responsible for making the move to cloud desirable for the organization through workforce preparedness, communications, training, resource, and career management plans. Next, feasibility from a technical delivery perspective, as well as operability of the products in production. And since the cloud platform engineering teams run in a true DevOps, you build it, you run it model, the engineers on the team are responsible for both across platform, operations, and security domains. These engineers work closely with the architects on the team to ensure that what they design can actually be built, and what is built is functionally and operationally excellent. Lastly, there are 2 additional roles on the Cloud Foundation team. These may be separate individuals, or they may be additional hats being worn by others on the team. An engineering manager that is accountable for team execution, technical delivery quality, team member performance and development, and overall HR responsibilities. And for teams practicing the Scrum form of Agile, a Scrum Master that facilitates Agile processes and ensures forward progress towards business outcomes by the team. Think big, but start small. Launch a Cloud Foundation team and a number of development teams to start your flywheel, and then scale as your cloud transformation accelerates and expands. Next, we'll show you some of the models of how the Cloud Enablement Engine scales with your adoption of AWS. Every customer journey is different, but we do want to share some patterns that we see being successful with other customers as they grow their adoption of the platform. We've already covered the Cloud Foundation team. This is the team that is going to put your AWS Foundation in place and enable your first few development teams and workloads to migrate to AWS. As the number of development teams, applications, and cloud enablement products grows, you'll likely have to do something that we call subdivide and specialize. For your initial Cloud Enablement Engine, we'll split the Cloud Foundation team into 3 more specialized product teams. The first split is to create a dedicated product team to handle your Cloud Business Office functions. And as part of this split, you will also create dedicated cloud platform engineering capacity. In this example, we have 2 product teams, each with a balanced set of platform, operations, and security engineers, as well as a product owner and a Scrum Master. While it's tempting to create teams that are organized and specialized in a single domain, platform, operations, and security, our recommendation is to keep the teams cross-functional and cross-domain. This promotes knowledge sharing between platform, operations, and security experts, which will create more well-rounded products as well. Otherwise, you're recreating the activity-based teams we talked about at the beginning of this webinar. This also facilitates easier team workload and capacity balancing for new products. It also enables easier scaling of your product engineering teams. For large organizations, supporting an even larger number of development teams, applications, and cloud enablement products, we'll subdivide and specialize again. We'll split the Cloud Business Office into 3 distinct product teams. A business and governance team focused on architecture, product management, delivery management, and financial management. A customer onboarding team focused on hands-on consulting and enablement of development teams, and a training and org change management team focused on large-scale training and enablement of the organization to successfully adapt to their life in the cloud. We will also auto-scale the capacity of the cloud platform engineering function to 3 product teams for additional engineering and operations capacity of our cloud enablement products. Your Cloud Enablement Engine may evolve differently, but this gives you a good idea of the journey that your organization is embarking on. Our recommendation is to build your Cloud Enablement Engine from the talent that you already have within your organization. This slide depicts mappings from current state roles to what we see customers adopting as they move to AWS. As you will see, in many areas there is a narrowing of roles as our platform does a great deal of the heavy lifting traditionally required by infrastructure and platform teams. These slides will be provided to you as part of the webinar. As part of creating these new roles, we also recommend a comprehensive approach to training and education. As you can see here, we have different levels of training to accommodate different levels of experience, as well as areas of depth that will align with the cloud roles that we saw on the previous page. In closing, we'll leave you with a set of 4 next steps. Number 1 would be to think about the questions on the previous slide internally, and then think about scheduling a people and operating model workshop where we can help dive into all of the product-based operating model components we discussed during this webinar in greater detail and how they would apply to your Cloud Enablement Engine, as well as potentially your software development teams. If you're thinking about migration and our migration readiness program, we highly recommend creating your Cloud Foundation team, that initial small two-pizza team, to help enable the success of that migration readiness. And then finally, number 4, if you're working with an AWS account manager, please inquire about additional briefings, workshops, and other migration topics that could include building your cloud business case, various security topics, as well as potentially scheduling a migration immersion day. That concludes our webinar for today. Thank you so much for tuning in and for spending the time with us.